All right, well, this is going to work. To those of you that came into the Zoom meeting, thanks for trying. Uh, and yeah, 3 times getting kicked out was enough. Okay, so I've got a cool demonstration to start things off for today as we look at how we can use friction to create a charge imbalance in two objects. Basically, this is how we can make static electricity, or how we can see it in action. So I've got a plastic straw, got some pieces of aluminum foil, and I have a little bit of the paper wrapper that came from this straw. And I have a shirt made out of cotton. And so I'm going to take this shirt and just rub it on the straw. Now, obviously, the straw and my shirt are made of different things. One of these things is going to be more of an insulator than the other. So one's going to be more of a conductor, one's going to be more of an insulator, and that is important in that it moves the electrons around a little bit. The thing that's more of an insulator is able to keep its electrons, but also steal some electrons from my shirt. This act of friction gives the electrons enough energy to jump ship, to leap off my shirt and get picked up by the insulator here. And we can do all kinds of cool things, like make things levitate. All right? It's really pretty cool. So, what's going on? Well, let's see if we can explain what's going on in about 10 minutes. So, first of all, we've got a little warm up here. If you haven't done it yet, please do it now. Welcome back. And so affinity, what's affinity mean? Affinity means attraction for things. So if you have an affinity for chocolate, you're attracted to it. We bring this up because we think about electron affinity. Certain things, certain materials have a real love or attraction for electrons, more so than other materials, right? Like this thing, this straw, had a greater love of electrons than my shirt. My shirt doesn't care as much about electrons, and so it gives them up more freely than this straw does, and that's why it was able to become negatively charged, and then it attracted these neutral pieces of aluminum and neutral pieces of paper. They had a different charge, right? Remember? Like charges attract, opposites. Ooh, I said that wrong. Like charges repel, opposites attract. There we go. Okay, one of the things I just said is in your guided reading, and I've put the answers to the guided reading here. And so you can go through those and take a look and fill in some gaps, some important bits. Oh, sorry, wrong document. There we go. There we are. So we're defining electrostatics, electrical forces. So there's a force of attraction and repulsion. You haven't really experienced this much in your life, but you have experienced maybe rubbing a balloon on your head and feeling that tingle, right? You rub and then you feel the little tingle as your hairs get attracted. Now, those are electrical forces. Similar to these would be magnetic forces. You take two magnets and you put them together, and if they're opposite, they attract. And if they're like charge or like poles pointing at each other, they repel. So you feel those forces, and that's very similar. What else? You need to know about electrons, protons, and neutrons, the things in the atom. Electrons are negatively charged. They're an E symbol with a little E with a little minus sign next to it. Protons are positive with a P, and neutrons are neutral with an N. And every atom has those things in it. But sometimes if the protons and electrons are imbalanced or not balanced, then you'll get a charged atom, right? Either with a positive or a negative charge, and those are considered to be ionized. All right, we've got some things that are attracting and repelling here. I've put the signs there and there, there and there, there and there. And charge is conserved. So like when my shirt gave up some electrons, They didn't just disappear. They went to the straw, but they still existed. They weren't gone. What's that? Okay. Other important stuff. Coulomb's law. So there's as with most things, there's an equation that somebody came up with um, to explain the relationship between charge and how it affects things, right? If you rub this balloon on your head, if you keep the balloon close to your hair, you'll see some of the hairs start to stick up. But if you move the balloon further away, what happens? Well, your hairs fall back down because the force isn't strong enough. And so when forces decrease with distance, that's an inverse relationship. And it actually turns out that the force decreases with the square of the distance. And so it's an inverse square relationship. And so that looks like this. Hey, dude, it looks like this, that the force is equal to a constant times one charge times the other charge divided by the square of the distance between those two things. This constant is 9 times 10 to the 8, I believe. 1, 2, 3 times 10 to the 9. Newton meters squared divided by Coulomb squared. Here's the equation again. So we've got our force, we've got the product of our charges, we've got the constant, and then we have the distance squared. And there's the alarm that Jackson has class for art in 5 minutes. Are you excited?
No, I'm not excited.
Do you like online school?
Online school is thumbs down.
Yeah. All right. That's it for that stuff. Let's go through the rest. Okay, I'll help you in just a couple minutes, dude. Okay, so this is a cool way to think about how we charge things by friction. This is what I did with my shirt. So there's a couple links that you can click on right here. These, I know they don't look like links, but they are. You see my cursor changed, and so you can click on those to read. Nobody, not right now. After, remember, I'll show you how to do this stuff. So while you're looking at the reading, you can go in and answer all this stuff. I'm going to talk about what's down here, right? Because you can figure this out. What's negatively charged? Electron. Protons are positively charged. It's pretty easy, fill in the blank. Here's a great example. So here's a plastic strip that was rubbed with cotton and became charged. So why is this charged? Well, did it get extra protons? Well, no, protons can't move. All right, so the only thing that can move is electrons. So that'd be the answer there. Here's something really cool. We got the Triboelectric Series. So some materials are more electron greedy than others. The Triboelectric Series is a listing of materials that puts those materials in order of relative attraction to electrons. Things at the top have a stronger affinity for electrons. Things at the bottom, weaker affinity. So here we go. We've got cotton. We've got celluloid. So when I rub my shirt, you can see that my shirt's made of cotton. This is made of celluloid, and so there's going to be a difference in affinity for electrons, and the celluloid is going to be more electron grabby. When I put the celluloid together with something that's metal, again, there's a difference. And so you're able to see that when I was able to pick these up. There's lots of other common examples for this down here. All right, we've got a cotton sweater. When you take that off, right, you take it off and it goes, right? Maybe you've heard that. Maybe it makes your hair stand up when you do it. And so think about the charges there. All right, there's going to be a difference in charges. So think about what those are. And you can, again, use this. We've got cotton. Here's cotton there. And here's skin, which has a greater affinity for electrons. Well, cotton's near the top of the list. Skin's a little bit lower, so cotton is going to have a greater affinity for electrons than skin. It's going to steal some electrons from the skin. And when it does that, that's that ripping sound that you hear when you take the sweater off. So lots of true and false and other questions to think about. And again, resources for these are here. And then I've also provided some at the bottom of day 165 right here. So take a look at those. And that's it for the day. And we'll come back and talk about the answers to these tomorrow. All right. Have a great rest of your day.